Coldest temperatures on Earth have been recorded. Every year, a few hundred scientists spend months in the Antarctic. But what happens to the human body at such extremely cold temperatures? Now, we all know from shivering through even our mild British winters that our bodies aren't exactly cut out to cope with extreme cold. Now, in all these clothes, I'm pretty fine at -20, but as soon as I start removing bits of clothing, I'm going to lose heat very quickly indeed. We've got a thermal imaging camera here, so you'll be able to see. I'm going to start by taking my gloves off.
Well, the first thing that you'll notice if you're standing in -20 degrees centigrade and you have a lot of clothing on you is that your body is not losing very much heat through the clothing, and that's why it appears blue, because in this particular colour scheme, blue is cold and red is hot. But you'll notice that your hands and your face, which are unprotected, are losing a great deal of heat.
Right, both gloves off. Now it's for the hat moment. I've heard that you do lose most of your heat through your head.
Well, things are really hotting up here. As you can see, you've taken off your top jacket and now you've only got a thin layer on and you're losing an enormous amount of heat, and this could be really quite dangerous. And the surface of your clothing is now a temperature around 11 degrees centigrade, but look at your bare arm. This is now losing heat at an enormous rate. But look, this is really very fascinating because the temperature of your hand here has begun to fall. So now the temperature of your hand is down to around 3 to 4 degrees. It's lower than that of the surface temperature of your arm, and that's because the blood supply to your hand is shutting down. It's vital to preserve your core temperature. And the body does this by shutting down blood flow to the extremities, which means that although you may lose a few fingers to frostbite, you actually save your life.
In 1912, Captain Scott and 4 of his team died of exposure because the woolen trousers and jumpers they were wearing could not protect them from the bitter cold. These days, it's very different. The British Antarctic Survey has been sending scientists to work in these conditions since 1944. And due to continual improvements in the equipment and clothing they're sent out with, none have ever been lost to exposure.
Every year we have a system of feedback where we ask for people who've been to the Antarctic to give us information back as to what they've had, whether it worked for them, if it didn't, why didn't it, and then we develop the clothing system from their comments.
Paul, talk me through basically what I was wearing and why they worked.
Well, we use layer principle, lots of layers that you can build up, take down, depending on how cold or warm the conditions are. You're wearing a base layer.
Yeah, so these are like thermal underwear, basically.
Exactly. It's a wicking fabric that allows moisture to be transmitted away from the skin surface to leave a warm, dry layer of air next to your skin. The thing you want to do is avoid staying damp, because damp means that the cold then is able to sort of build up next to your skin. Then you start to chill, and you want to avoid chilling at all costs.
And is that why? Because are these synthetic?
That's right. They're synthetic materials, but they move moisture away by transmitting the moisture along the fibres out into the mid layers and then out into the atmosphere.
Right, so the whole process, you're basically trapping in your body warmth,
that's right,
but drawing moisture away.
Exactly.
This is what we're effectively doing.
Yes.
So presumably it's not just clothes that are essential. You've had to organise all sorts of other systems to keep people alive.
That's right. We've got a totally integrated living system that we issue to our field parties, which is their accommodation, their sleeping, their food, is all taken care of. This is a 2-person pyramid tent. The design is a proven design. We know this tent will survive 100-knot winds. We have great faith in this tent, so we know it works. It's very durable, it's very robust. There's no need to change it.
Okay, so this is our sleeping system. How does this work then?
That's right. Again, lots of insulation, keep you away from the cold ground. A self-inflating mattress, a closed cell foam mat, again, extra insulation. Sheepskin rug.
Oh, they're like Princess and the Pea, aren't they, this lot? They're really pampered.
And then your sleeping bag, which has a canvas cover to keep your porridge and your tea off it, to make sure you don't ruin your bag. And then an 1100 gram downfill sleeping bag.
So this is it, the gourmet feast. Now presumably this is just when they're working away from the base.
That's right. But out in the field, yes. This is your man food box. This contains enough food for one person for 20 days at a rate of 3,500 calories per day.
Which is, how much more is that than a kind of regular intake?
Regular intake is probably around about 2,000 a bit, so it's half as much again.
That extra energy is needed because as well as keeping warm, everything in the extreme cold takes longer and requires more effort. But while British scientists and explorers have taken years to develop techniques for surviving in the cold, one group of people, the Inuit, who live in the Arctic Circle, have been handing down their method for generations. They make use of the materials naturally available to them.
This is, if you like, the original anorak. In the Iglulik dialect, it's anurak, and it means a piece of clothing, any piece of clothing. Inuit have many different materials to keep them warm. The most important thing is caribou. Now, caribou is uniquely good for insulation because the hairs themselves are in the form of bubbles. If you look at them under a microscope, you see this extraordinary bubble structure. So it's rather like wearing clothing made of hairs, each of which is like a piece of bubble wrap or like a piece of Aero chocolate. For boots and also for waterproof clothing, sealskin is most important. And in most of the Canadian Arctic, Inuit use ringed seal for trousers and for the uppers of boots. And then they use bearded seal, which is a much larger creature, for the very thick skin that's needed for boot soles.
For those going to the Antarctic, it seems that the high-tech has won over the traditional natural fibres passed up for man-made ones. But it doesn't stop here. Clothing developers still think they can go further in keeping us warmer and therefore safer in extreme cold conditions.
I think there's still quite a long way we can go in terms of fabric developments. We're trying to study the physiology of the body more so that we can construct the fabric so that you can make it cool you in the areas where you're going to overheat more, but be thermally better in the areas where you're less likely to overheat. And also we're trying to look at the ways we can vary the stretch of that fabric so that it can move with the body in the right places.
As they think about future developments, clothing manufacturers like Carrymore are looking to other industries for inspiration.
Some people are looking at how you can incorporate electronics into garments. Polartec have made some developments where they've knitted in heating elements into panels which you put around the kidneys, which are particularly prone to heat loss, and that's connected to a mobile phone battery, and you can just provide some heat when you need it.
Who would have thought that mobile phones could be good for you? It's rather like Formula One, where cutting-edge technology eventually appears in the family saloon. The clothes developed for life on the edge in Antarctica also filter down to keep us warm and protected on the slopes.